In this video, we are going to look at angles of elevation and depression. So, a great way to understand angles of elevation and depression is to imagine this. Let's say we have like a cliff or something that's really, really high. Okay, let's imagine that you're standing at the bottom, okay, here. And imagine that your friend is standing at the top. Okay, now let's talk about angles of elevation first. Let's say you're looking up at where your friend is standing. Okay, so you're looking from here to here. This is your line of sight. Now, what the angle of elevation is, it's the angle between the ground and your line of sight. Okay, so the angle between like the horizontal ground and the line of sight to where like you're looking up at to your friend. This is our angle of elevation. Okay, in other words, how elevated is your line of sight up off the ground? Conversely, angles of depression, okay? This is, well, imagine if your friend is looking, okay, horizontally, and then looking down at you this way. This is their line of sight, okay? The angle of depression is the angle between that horizontal here, and the line of sight, their line of sight to you, okay? This is your angle of depression here. Now, what's really, really important is that your angle of depression is not this one, okay? This is wrong because your angle of depression is always measured from the horizontal to the line of sight that way and not from the vertical cliff or building or whatever to your line of sight that way, okay? So really important to recognize from the outset that this is not your angle of depression. Very common mistake to think that it is, okay? So make sure we're labeling the correct angle. Okay, so now that we know what each one is and what they actually do, let's get into some problem-solving questions of what you might actually see each of these things come into play. So for this one, we have a man, he's looking up at a tall building. If he is 25 meters away from the building and the angle of elevation to the top of the building is 40 degrees, we need to find the height of the building corrected 2 decimal places. Now, before we even dive into this question, let's just kind of agree on a general method that we should use when approaching these problems. First step, we always need to draw a diagram for these problems just to find out what's happening where and what's doing what. Then, of course, we need to solve, okay? We need to solve our problem using our understanding of trigonometry to do so. Okay, so let's do step number 1. Let's draw a diagram, okay? So we have a man and he's looking up at a tall building, okay? Let's just say the man's over here, small dot. He's looking up at a tall building over here, okay? Building is there. And there we go, I've drawn a bit of a triangle because that tall building is at right angles to the ground. That's an assumption we can safely make. Now, we're told that he's 25 meters away from the building. Okay, so he's 25 meters away from the base of the building there. And we're also told that the angle of elevation, so this angle here to the top of the building is 40 degrees. And we need to find the height of the building here, correct to 2 decimal places. Okay, so see, just by talking through that, we've already got our diagram. We've got our right angled triangle that we need to work with. Okay, so step number 2, let's just go on and solve the thing, okay? So here we're dealing with, here's our angle of interest, opposite side over adjacent. In other words, we're dealing with our tan ratio. So we know that tan, 45 degrees, is equal to our opposite side h over our adjacent side 25. Let's rearrange, make h the subject, times 25 on both sides. So then we'll have h is equal to 25 times tan 45 degrees. And when we do that, we'll get 20.977 ... which, when rounded, is going to be 20.98 meters, and that is correct to 2 decimal places. Excellent. So just to quickly recap that question, we started off with drawing our diagram. Okay, make sure we're correctly identifying the angle of elevation. And then, of course, we apply our trig ratios to solve. Might I suggest that with these questions, you very rarely are you going to be using cos or sine, because very rarely will you want this side here, the hypotenuse, okay? Remember that tan is the only ratio that deals with opposite and adjacent. Okay, now this question here is a bit of a slight variation from the style of question we just did. We have a woman standing 15 meters away from the base of a tree. She measures the angle of elevation as 25 degrees. But this time we're actually given the woman's height, and then we're asked to find the height of the tree. Okay, so before we kind of talk about it, once again, method is draw a diagram, then after that solve. Now, the diagram is going to be a bit different because we need to factor in the woman's height. So we've got the woman, let's just say, okay, well, since we're factoring in her height, let's just draw a stick figure. And we know the base of the tree is going to be like somewhere here. So we know that the distance between the woman and the base of the tree here is going to be 15 meters. She measures the angle of elevation to the top of the tree as 25 degrees. So imagine this is the top of the tree. Now, because we're factoring in the woman's height in this question, okay, what we need to kind of keep in mind is that the horizontal from which the angle of elevation is measured starts from here, from where the woman's eyes are looking at, right? So that's going to be our horizontal, and then our line of sight is actually going to be here. Okay, so it's a little bit off the ground. It's a bit different to the question we just looked at, where everything was kind of on the ground already. Here, we're standing a bit above the ground, and we need to factor that into consideration. Okay, so let's just keep drawing this diagram. We know this is the top of the tree, and we know the tree is going to come all the way down here to the ground. We know that this angle here is going to be 25 degrees, okay? We know that this distance here is also going to be 15 because it's just from where she's standing to the tree, so that's also going to be 15 meters. We know we can safely assume this is a right angle and that the horizontal is perpendicular to the tree. And importantly, this distance here we know is going to be 160 centimeters, or in meters, it's going to be 1.6 meters, okay? So here's our diagram. Now, when it comes to solving this, we can kind of break this problem up into two distinct steps. First of all, we need to find what this height is. So I'm just going to say h1. Then, after we've found what that height is, then we need to find our total height, ht, let's say. So let's start off with finding h1, okay? Using this triangle here, we can see we've got our angle of interest, our opposite side, and our adjacent side. So we're using tan. So we have tan 25 degrees is equal to our opposite side h1 over the adjacent side 15. Then let's solve, times that 15 up on both sides. So we'll get h1 is equal to 15 times tan 25 degrees. And when we perform that calculation, we'll get h1 is equal to something like 6.99, which can be rounded off to 7 meters, and that's just to the nearest meter. Okay, so that's step one of the problem done, but we still need to find the total height. So h total is going to be that 7 meters, which is h1, plus the 1.6 meters of height for the woman that's looking at the tree. So when we add 7 meters to 1.6 meters, okay, this will be 8.6 meters, okay. Now, bear in mind the question's asking us to find this correct to the nearest meter, so then we can just say h total is going to be approximately equal to 9 meters, and we'll need to indicate that's to the nearest meter. Okay, let's box that. Okay, so this question, it's similar to the one we just did previously, same steps with constructing the diagram, apart from the key difference, which is we need to factor in the person's height here. Okay. Now let's look at our final problem where we're dealing with angles of depression. So the key thing about this question is making sure that we correctly label where our angle of depression is. So I'm just going to dive straight into that one and start drawing the diagram as we're reading. So we have a bird sitting at the top of a lighthouse, okay, watching a boat from a distance. Let's just say the boat is over here. And the angle of depression from the bird to the boat is 30 degrees, okay? So remember, angle of depression is measured from our horizontal to the line of sight, so it's going to be this one here. Now, if the lighthouse is 45 meters tall, so in other words, from there to there, it's going to be 45 meters, and presumably, assuming there's no cliff to take into account as well, if the lighthouse is 45 meters tall, we need to find that horizontal distance, so this distance here, between the bird and the boat, correct to the nearest meter. Okay, so we've got our triangle. Now, critical thing to recognize with this problem is this. Well, in this triangle here, we don't have an angle in there just yet, okay? But in saying that, our horizontal, our horizon, that's going to be parallel to our ground. Okay, those two lines never meet. And we'll also remember from our study of angle theorems that if we have like this Z configuration here on parallel lines, it's what we call alternate angles, right? Or Z angles, where whatever we have here is going to be equal to this angle here. So in other words, that's a quick way for us to get that 30 degrees into our triangle here. Now from there, we can just apply our trig ratios. So there's our angle of interest, we've got our opposite side, and we've got our adjacent side. So then we're using tan. Tan 30 is equal to our opposite side 45 over our adjacent side D. Now let's solve, okay? I'm just going to flip each of those fractions. So I'll have D over 45 on this side, and on this side, because tan 30 is the same as tan 30 divided by 1, I'll have 1 on tan 30. Just flipping those so D's on the top here. Okay, now let's solve. All we need to do is times 45 across. So then we'll have D is equal to 45 times 1 on tan 30. And then when we get that, we'll get D is approximately equal to, remembering we need to find this to our nearest meter. So I'm just going to go straight to the answer. It's going to be approximately equal to 78 meters. And once again, let's indicate what we are rounding to. Excellent. Okay, so just to summarize this question, remember, make sure we're labeling the correct angle of depression. It's this one here, not this one there. Also keep in mind alternate angles, because this will help get your angle into our triangle here. And then finally, we're continuing on with our working out as usual. Okay, that's it.